Hello everyone, my name is Flux from Chosun Welding. Today, let's take a look at the manual flux cord arc welding, which is used the most in welding process, which is within shipyard such as block welding.
The product name is CSF71S. This is a flux cord wire for all position welding that can be used by integrating 2 to 4 wide grade made by Chosun Welding. First, let's open the CSF71S product box. Inside the box is an aluminum vacuum packaging. I think it's a measure to prevent moisture absorption. This aluminum packaging is difficult to tear with bare hands, so use a tool near it to open it. Cut the end of the wire and straighten it and insert it into the feed cable. Press the inching button to check if the wire comes out well. The wire comes out well. The setting is now complete. Now, one thing to note here is that the wire on the spool may come loose from the feeder. In this case, it is better to cover the spool protection cover. Usually, thick PVC material, leather cloth, or plastic is used to prevent the wires from coming off. However, there are quite a few welding machines without the protection cover, and these machines will have other ways to fix the spool. In particular, shipyard manual flux cord wire welding requires a lot of welder skills, so it is important to know the proper welding method. The most common defects in shipyard manual flux cord wire welding include pore defects, lack of fusion, lack of penetration, slag inclusion, burn through, undercut, overlap, surface and profile, and excessive spatter. Understanding the welding principle can prevent the above defects. Let's take a look at the welding principle of manual flux cord arc welding. The proper current and voltage conditions for each welding position should be used. For vertical up welding, we recommend drag angle of 5 to 10 degrees. If angle is too big, it may cause penetration problem and the root part may not be melted. If angle is too small or minus, bead profile may be too convex. Let's learn about welding drag method at flat position. Basically, I'll explain the post-weld phenomenon of the backward and forward welding. Backward welding is the most commonly used welding method in flux core arc welding. It has deep penetration and beaded convex. Forward welding method is thin penetration and flat beads. Drag angle uses 10 to 20 degrees when using forward, backward welding. If you weld at 0 degree, which is the right angle, you can get the result between the forward and backward welding method. If you put drag angle overly, then gas shielding problems occur and gas defects are easily generated. If the welding speed is too fast, the bead straightness is bad due to solidification of molten metal and slag, and humping beads may occur. If the welding speed is too slow, the oxidation of the alloy due to excessive heat inputs may increase, which may reduce the mechanical properties of the weld metal. In addition, if the base metal is thin, it may result in burn through. The wider CTWD reduces the currents, resulting in thinner penetrations, higher overlap, and shaking arc balance, resulting in high spatter. The CTWD is narrow. The current increases to deepen the penetration, increasing the melting of the welding material, reducing the straightness of the beads, and increasing the convex beads. Now, let's take a look at the welding phenomenon according to the shielding gas. And a high gas flow rate can cause a lot of oxidation of the molten metal, which can lead to poor mechanical properties. If you weld with the gas belt locked, you will see an explosive amount of spatter and many gas defects, as you could see. And a low gas flow rate makes it easier for gas defects to occur.
Today, we learn about the manual flux core arc welding. Did this video help you a lot? You have any question? Please leave your comment. We'll produce a video with the content you are curious about next time. So goodbye.